Welcome everyone. I'm excited to kick off today's presentation. Today we're going to explore the fascinating world of physical geography. The title of our presentation is Unveiling Our World, Fundamentals of Physical Geography. Over the next few moments, we'll cover the key concepts that help us understand the Earth's physical features and processes. So let's get started and dive into the wonders of our planet. Let's explore the key takeaways that help us develop a holistic understanding of our planet. First, we have Unit V, water, the lifeblood of Earth. Water is essential for all life forms and shapes many of our natural processes. Next, Unit III, landforms sculpting the surface, which highlights how the Earth's surface is constantly changing through natural forces, creating mountains, valleys, and plains. Moving on to Unit II, the Earth, our dynamic home, emphasizing that Earth is a constantly evolving planet with dynamic systems. Then, Unit VI, life on Earth, biodiversity and conservation, reminding us of the rich variety of life and our responsibility to protect it. We also look at Unit IV, climate, the blanket of our world, which influences weather patterns, ecosystems, and human activities. Additionally, we consider how continents drift and seas shift, illustrating the dynamic nature of Earth's surface. And finally, we recognize that geography is more than just locations. It's about understanding the relationships between physical features and human activities. All these points tie together to give us a comprehensive view of our planet's interconnected systems and the importance of understanding them in our ongoing exploration of Earth's complexities. Now, let's look at how geography is truly a dynamic discipline. It goes beyond just knowing where things are. It's about exploring the spatial distribution of various phenomena across our planet. This means examining how natural and human-made features are arranged on Earth's surface. By doing this, we can uncover patterns and understand the interconnectedness between different elements. For example, how human societies influence their environment and vice versa. This relationship is at the heart of what geography studies. Furthermore, an interdisciplinary approach allows us to integrate insights from fields like geology, biology, and sociology. This helps us build a more comprehensive picture of our world. Understanding these connections enables us to see the reciprocal influence between humans and nature. It's about recognizing that our actions affect the environment, and in turn, the environment influences our lives and societies. So, geography isn't just about locations. It's about understanding the complex, dynamic interactions that shape our planet. Let's talk about how denser materials sink to form the Earth's core. This process is called differentiation. Essentially, when the planet was still forming, gravity played a key role in gathering the heavier, denser materials towards the center. This movement allowed the core to develop as a distinct layer, separate from the mantle and crust. Now, moving back a bit, planetary accretion was the initial step in Earth's formation. It all started from a solar nebula, a giant cloud of gas and dust orbiting our young sun. Over time, particles collided and stuck together, gradually building up the planet. And this entire story, from cosmic dust to a fully formed planet, is part of our cosmic origins. Understanding this helps us see how Earth evolved from a fiery, chaotic beginning into the vibrant, dynamic home we know today. So, in summary, the process of differentiation and planetary accretion are fundamental to understanding Earth's structure. They explain how the internal layers formed and give us insight into the early processes that shaped our planet. Now, let's take a closer look at the Earth's layered structure. First, we have the crust, which is a thin, solid, rocky surface. It's the layer we live on, and even though it's thin compared to the other layers, it's incredibly important because it forms the land, oceans, and everything on the surface. Beneath the crust lies the mantle, which is a thick, viscous silicate layer. This layer is less solid than the crust and can flow very slowly over time. It's responsible for some of the Earth's internal movement, like convection currents, which drive geological phenomena. Moving deeper, we reach the outer core. This is a molten, convecting liquid layer made mostly of iron and nickel. The movement here creates Earth's magnetic field, which is vital for protecting us from solar radiation. Finally, at the very center, we have the inner core. It's a solid iron-nickel center, extremely hot but under immense pressure, which keeps it solid despite the high temperatures. By understanding these layers, from the thin crust to the solid inner core, we see how each part plays a crucial role in shaping our planet's geological activity, from volcanoes and earthquakes to the shifting continents. These processes are driven by the internal heat and movement within the Earth, highlighting how dynamic our planet truly is. Imagine a time long ago when all the continents were joined together in one massive landmass called Pangaea. This incredible idea helps us understand how Earth's surface has changed over millions of years. Plate tectonics is the key to explaining many geological features we see today, like mountain ranges, volcanic activity, and even where natural resources are found. So, how did these vast oceans and continents come to be distributed as they are now? Well, that's where the revolutionary theories of continental drift and plate tectonics come into play. These theories reveal that Earth's surface isn't static. It's a dynamic mosaic of moving plates. Think of Earth's crust as a giant jigsaw puzzle made up of several large and small pieces. These are the tectonic plates. They are constantly shifting, drifting apart, colliding and sliding past each other. This movement shapes the continents and ocean basins over geological time. Understanding this process helps us see the Earth not as a fixed, unchanging sphere, but as a living, breathing planet in constant motion. It's a fascinating story of change, one that continues to unfold beneath our feet. So, moving on to slide 7, let's talk about how the Earth's surface is constantly changing. Forces like weathering, erosion, and deposition are at work all the time, shaping the landscape around us. Weathering breaks down rocks into smaller pieces, erosion moves those materials from one place to another, and deposition finally settles those particles, forming new landforms. These processes are ongoing and dynamic, and they're key to understanding how our planet's surface evolves over time. They work together continuously, sculpting everything from mountains to plains, making the landscape a living, changing entity. Now, let's take a closer look at the role of humidity, clouds, and precipitation. These elements are crucial because they help regulate the Earth's energy balance and influence weather patterns. Humidity refers to the amount of water vapor in the air, which can vary greatly and directly affects cloud formation. When humid air rises and cools, water vapor condenses to form clouds, and eventually this can lead to precipitation: rain, snow, sleet, or hail. These processes are vital for distributing fresh water across the planet and maintaining ecosystems. Understanding these components ties into our broader discussion on water in the atmosphere, which is a key part of the Earth's climate system. They also connect to how energy moves through the atmosphere, balancing incoming solar radiation with outgoing heat to keep our climate relatively stable. By grasping how humidity, clouds, and precipitation work together, we better understand the dynamic nature of weather and climate, how they can change rapidly, and how they are influenced by larger patterns like atmospheric circulation and solar energy. This knowledge is essential as we explore the impacts of global warming and climate change, which can alter these natural processes and lead to more extreme weather events. Oceans cover over 70% of our planet's surface and are absolutely vital for sustaining life. In this unit, we're diving deep into the mysteries of the marine world, exploring the properties of ocean water and the powerful movements within it. One of the key concepts to understand is how energy moves through water, which creates currents. These large-scale, continuous flows of ocean water are crucial because they influence global climate patterns and help distribute heat around the planet. Next, we have waves. These are the rhythmic rise and fall of sea levels caused by the gravitational pull of the moon and the sun. Waves are not just about the surf. They play a significant role in shaping coastlines and affecting marine ecosystems. Then there are tides, which are driven by gravitational forces as well. Tides cause the water level to rise and fall predictably, and they influence many marine activities and ecosystems. Moving deeper, the circulation of the ocean's interior is driven by density differences. Density is affected by factors like temperature and salinity, which are essential for regulating currents and, ultimately, the climate. Temperature influences how warm or cold the water is, affecting marine life distribution and the behavior of currents. Meanwhile, salinity, the salt content, affects the water's density and determines what kinds of marine life can thrive in different areas. Together, these properties, temperature, salinity, density, interact to create the complex and dynamic system that drives ocean currents and climate regulation. Understanding these elements helps us appreciate the ocean's role as the lifeblood of Earth, connecting all these processes in a continuous, powerful cycle. Let's take a closer look at the incredible variety of life on Earth, from tiny genes to vast ecosystems. Biodiversity is the term we use to describe this rich diversity, and it's essential for maintaining the health of our planet. Moving on, we have biogeochemical cycles, which are the natural processes that move elements like carbon and nitrogen through Earth systems. These cycles are vital for supporting life and keeping our environment balanced. Next, conservation is all about protecting and managing our natural resources and the species that depend on them. It's a crucial step in ensuring that future generations can enjoy the richness of our planet. And then, we have ecosystems, interacting communities of living organisms and their non-living environment that form the foundation of life on Earth. All of this is part of the larger biosphere, where every form of life exists within a complex web of ecosystems supported by intricate biogeochemical cycles. Throughout this presentation, we've explored how interconnected and vital these components are, emphasizing the importance of conserving our planet's natural heritage for the future. Now, as we come to the final slide, let's revisit the key takeaways. Geography helps us see the Earth as a set of interconnected systems, emphasizing a holistic understanding. It's not just about facts, it's about understanding how different parts of our planet influence each other constantly through dynamic interactions. This perspective is crucial because it guides us in making informed decisions about managing vital resources like water, minerals, and soil, decisions that are essential for sustainability. By grasping these fundamental concepts, we're better prepared to address global challenges and become responsible stewards of our planet. Remember, physical geography is more than just knowledge. It's a framework for understanding the complex, ever-changing world we live in.